Hi, I'm Wolfgang, and what we want to look at today is what happens when an object moves through a fluid. In particular, there's some interesting things that happen called vortex shedding. There's a certain range in velocities where vortices are formed, and what we want to look at today is the interaction of those vortices and the object itself. So the object is going to be a pendulum, and the fluid is water, and that's why we've got this big aquarium, which we've converted into a flow tank. So there's a barrier in the middle of the aquarium that separates one end from the other. At the far end, we've got a couple of pumps that pump the water from that end through these pipes down to this end. To keep the turbulence at a minimum, the water comes out through these socks and piles up at this end, and then the overflow goes down this channel back to where the pumps are, and the cycle repeats. And we'll put the object that we want to look at, which is a pendulum, right up here in this channel of water. Okay, we've turned on the pump and the water's flowing, and we want to get an idea of how fast it's really moving. We've put a meter stick in the water. It's graduated with 10 centimeter markings. And I'm going to put this ping pong ball into the water to see how fast it floats downstream. Fast upstream and about 10 centimeters per second the rest of the way. So let's put the pendulum into the water. It's suspended by these two rods, and we're placing it upstream where the water flow is fastest. And you can see that the shadows of the vortices and eddies that are formed are a little chaotic. And so any interaction with the pendulum results in very little motion. It just sits there in the flow, wiggling around a bit. All right, let's put the pendulum downstream where the water's flowing a little slower and see what happens. You can see it immediately starts moving back and forth, and you can see the shadows of the vortices being shed towards one side and then the other. My finger's following that. Every time the vortices get shed to one side, the pendulum moves in the opposite direction. And so the force on it alternates back and forth. Okay, now we've decreased the flow rate so that it's slower than 10 centimeters per second. Like before, when it was upstream, there are all kinds of eddies and vortices formed, but it's very chaotic, as you can see on both sides. There's no regularity to the interaction, and so the pendulum stays put.